you will see that an ellipse is the set of all points in the plane, the sum of whose fixed distances from two fixed points is constant. The two fixed points are called foci. So I'm going to draw this in on these ellipses here. If you have a wide ellipse, the foci will be like somewhere like right here and right here. Each one alone is called a focus, but there are two of them, so plural, it's foci. And then if it's a tall ellipse, it'll be somewhere like this. So these points right here would be your foci here. The center is always halfway between those points, and you can kind of, if I asked you guys to put a dot in the center, that's probably where you would have put it. So this would be our center here. And you also have two lines of symmetry. You have what we call a major axis, which is your longest line. So this would be your major axis of symmetry. And then if it's a tall ellipse, that would be your vertical line. And then we also have a minor axis. Sorry, I should have arranged these a little better here. So this is the minor axis. This would be our minor axis. So an ellipse is a type of oval, but it's kind of like rectangles and squares. Ellipses are always ovals. Not all ovals are ellipses. Okay, so it's a specific type of oval that we're looking at. So I'm going to flip over here to the document camera because I want you guys to see how you can make an ellipse. Here. So let me see if I can get this to show up. Okay, you can't see that little corner there, but I'm going to do this. It'd be better if I had a string because rubber bands are stretchy and they are not ideal. So normally I would have a string, but the string fell off of this. So the foci are our 2 points that we have that, in this particular case, I just have two, nails in a board. And so every point on our ellipse, I'm going to use this here, is going to be the same distance. Sorry, rubber band's not ideal. Same distance from the 2 points. So like right here, if I took this distance right here and added it to this distance, it would be the same as if I was over here. Or if I was over here. Or if I was over here. Or you can see, like I could travel all the way around. If this was a string, I could do this so much better. Those rubber bands are stretchy. But at any point, this distance here always stays the same. And these two distances have to add to be the same no matter where you're at on the scrap. So, so if you ever need to draw an ellipse, if you have two nails, you can draw a perfect ellipse with the string there just by taking your pencil and going around. Kind of like you guys are perfectly aware, I would say, of this, like if you had a string and you wanted to draw a circle. Rubber bands are terrible for this, but if I wanted to draw a circle, I could very easily just do this right here. And give me a lovely circle, give me a much better circle if that wasn't a rubber band with a stretch. But so it's sort of the same thing, but with the foci there instead. So, I used to teach ellipses, and I used to say that foci was just something that they wanted us to find, and you never, ever, ever would really use it, but they just wanted to ask us for it. But this is where math can help you out in life sometimes. I got another problem. I'm just going to give that to you as extra credit. I have found in my life that I have used ellipses and equations of ellipses and circles several times in my life for projects that I would not have thought I could have used them for. So my ellipses, I'm going to show you this. Several years ago, I wanted a sign to put in my yard that looked like this one right here. I thought it was so cute. I wanted it in my yard at Christmas time. And then I was going to order one. This, I've never seen one this expensive. This one's $600. The ones I saw were like $150, which still seemed a little bit expensive. So I thought to myself that I could just make that. That would be pretty easy. You know, at the time, a sheet of plywood only cost me like $20. It'd probably be like, might be $400 now, but not $400. But it's expensive. Lumber's up really high. But I just drew out the J. That was pretty easy to do. I drew out the Y. You know, use a yardstick. It was pretty easy because it's mostly straight lines. My problem was I knew when I did the O that I was going to have a hard time getting a perfect O because I was making it like 3 feet high, right? So that was going to be pretty difficult. So what I did is I knew that I wanted my ellipse to be like, 3 feet high and 2 feet wide. So I worked to find the coordinates of my foci, or like where they would be and how far apart they should be. So I put me 2 little nails there on the board, and then I could do what I did just here with that string and make a perfect circle. And then I shortened that up a little bit so I could make a smaller one on the inside, and it made a beautiful O. And I kind of had to freehand this stuff, which wasn't that difficult, but getting that O right was difficult. So it turned out pretty good. And I need a picture of like my actual sign, but I keep forgetting to take one and put it on my school computer. So it turned out pretty good for my craft project there, and I was super excited that I got to like actually write equations. I got a couple other times I have used equations of circles. I might make you guys like an extra credit problem or something for that, because they can be useful sometimes. So, oh, and I forgot, I didn't mark these. We also would call these points right here where the major and minor axis hit the actual ellipse, we call those vertices. There, so all of those points would be our vertices. So, standard equation of an ellipse is going to look like this. There are some major similarities to circles and some differences. So, you can see right here this x minus h squared and the y minus k squared. That looks just like our circle, right? We got a plus sign in between. Some differences is ellipses are always going to be equal to 1. And these numbers underneath our x and our y are going to tell us the distance we go from the center to the vertex. If it's underneath the x, it's horizontally. If it's underneath the y, it's going to be vertically. So let's just look at graphing one of these. Okay? So I've got x minus 2 squared over 25 plus y plus 3 squared over 9 equals 1. So this is already in standard form. So the center here would be at 2, negative 3. So I would just go to 2, negative 3 on my graph. And so underneath my x expression, I've got 25. If I take the square root of that, I'm going to get 5. That is the distance from the center to my vertex horizontally. So if I go to the right, 1, 2, 3, 4, 5, I'm going to put a dot here. And I go to the left, 1, 2, 3, 4, 5, and put a dot there. I'm also going to take the square root of this 9 right here, which gives me 3. And that's my vertical distance. It's underneath my y, so it's my vertical distance from the center. So 1, 2, 3, up and down, 1, 2, 3, right here. And then you're just going to do the best you can to draw in a nice, pretty ellipse there. They're not the easiest to draw well, but you can get an idea of what it would look like there. Okay, questions? You can see obviously here if that number underneath your x is bigger than the number underneath your y, it's going to make a wide shape like we have here. You can see on this next one the number underneath our y is bigger. So for this one, let's see, Lauren, what would the center be for this ellipse here? Good, 0, 2, so we put us a coordinate right there. That's our center. And then major for my horizontal vertices going to the left or right. How far should I go to the left or right? Mm-hmm. 2, yes. So go to the right 2 and to the left 2, taking that square root of 4 right there. And then Mia, how much should I go up or down from that center point? Good. So 1, 2, 3, 4, 5, 6 here. Here. And so you can see this one makes a much taller, skinnier ellipse. Okay, questions? Okay, this one asks us to write the equation of the ellipse. So we're just working backwards from what we did before. We want to find that center first, which is at, in this case, 2, 3. And so we would have x minus 2 squared. And we got y minus 3 squared. Ellipses always equal 1. And so horizontally, we would go to the right 1, 2, 3, 4, 5, 6, 7. 7 squared would give us 49 underneath our x. And then vertically, we would go up 1, 2, 3, 4. So we'd get 16 underneath our y. Yes? That's just generally, I think that I think whoever the mathematician was that decided came up with all this, discovered that if it equals 1, that it's in this form where you can just count for your vertices. We could change it where it's equal to something else, and we'll see that we're going to get some that are not in standard form that will not be equal to 1 in the beginning. But if it is equal to 1, it puts it in the standard form where you can just count up and down. If it's not, it turns into a hyperbola. So if you have a minus right here, it's going to turn into a hyperbola, which we will learn about tomorrow. So it just has to be, or it's not going to be an ellipse. Okay. All right. So if we have this one here, our center is at -3, 0. And that's going to look like this, x minus 3 squared. And then...
I didn't get that. Could you try again?
No. Yes, thank you, plus 3. And then... I don't really need this parentheses here because we're just going to have y squared here. And to the right or left, how much do I go? 3, which means I'll have a 9 here. up or down, 7, which means I'll have a 49 here. Okay, questions? Okay, so we sometimes need to find the foci of an ellipse. So I have this example here, and the way that we find the foci, first of all, they were always on the major axis. So even if the question has not asked me to graph a picture, I at least want to think about a really rough graph of what this looks like. So if I have a 25 underneath my x and a 9 underneath my y, is that going to be a wide ellipse or a tall ellipse? It's going to be wide, right? It's wider than it is tall. So it's going to look something like this, and it's going to have a center right here. What are the coordinates of that center? 2, -3. All right. So we start from the center, and we need to have a picture of which way this ellipse faces before we start. And so we're going to take our A and our B values and plug them into this formula. So A would be 5 and B would be 3 in this case. So essentially you're just squaring them again. So it's going to end up like this. C squared is going to be the absolute value of 25 minus 9. Basically you're just subtracting your denominators here. And so C squared, the difference between 25 and 9 is 16. And you got absolute value bars. The absolute value bars just make it where you're always going to get a positive number there, so you don't have to square root a negative. So we got C squared is 16. We will square root both sides, so C will equal 4. Technically there's a plus or minus there, but we don't really need it for what we're doing in this case. This is what we call our focal length, or sometimes they'll call it width. It's the distance from the center to the foci. So what it tells me is from this center point, I would go to the right 4, and there would be a foci, or focus, and then I'd go to the left 4, and I would have a focus there as well. So if I want to know the coordinates of these points right here, if I start, turn that up. If I start over here at 2, -3, that's our center, and I move to the right 4, what are the coordinates of this point? 6, -3, right? Does not change my y coordinate because I'm just moving left or right. Just adds 4 to my x coordinate. What about it from the center to the left? I'm just going to subtract 4 and I'll get -2, 3. So my foci in this case are -2, 3, and 6, -3. I'm sorry, that should be a -3 right there. So -2, -3, and 6, -3. Okay. This formula right here is something, there's going to be a short formula sheet that you're going to get to use on this test. These are not going to be on the midterm, so you're not going to need it for the midterm, but when we get to test time for this, which will be next week, because this is a pretty short section, you will have a formula sheet with this on it there. Okay, so we want center and foci of these ellipses. So, Manuel, if we're looking at the first one, what's our center? -4, +10. Very good. And so to find my focal length, I'm going to say c squared equals absolute value, and I just subtract these denominators, 121 minus 81. So c squared is going to be the absolute value of 40. So if I just square root both sides there, c is going to be the square root of 40. You might see them change that to 2 root 10, just depending on what's happening here. So CB, am I dealing with a wide ellipse or a tall ellipse in this case? It's wide, right? And so right here is -4, 10. And so what I've just found tells me I'm going to go to the right 2 root 10, and I'm going to go to the left 2 root 10, and those are going to be my foci whenever I do that. So if I move it this time, I got 2 root 10, which is not, like, I could get a decimal and have an actual number there. It's not an even number like it was for the last one. Okay. All right, so if I'm moving to the left or right, which coordinate is that going to affect? X coordinate. So the way I can write my foci here is like this. I could say -4 plus or minus 2 root 10. And then just put comma 10. So you would add 10 to move to the right. You would subtract 10 to move to the left. These would be the coordinates of your foci. This is actually 2 points because one of them would be -4 plus 2 root 10, 10. And the other one would be -4 minus 2 root 10, 10. So probably your answer choices are going to look like this. You could always, if you needed, like, for example, if you were trying to create your own yard sign like I was, and you found this value, you'd probably want to get a decimal because you want to know how many inches long that is, so you can set that up. But for like problems that are just asking for this, you'll probably see roots here. All right, let's look at number 2. Matthew Pelkey, what is the center of that one? 2, 0. And Wesley, is that going to be a wide ellipse or a tall ellipse? Okay, it's going to be tall. There, right? So my center is right here at 2, 0. And I'm going to do c squared is the absolute value of 36 minus 49. And 36 minus 49 is going to give me -13. But then when I do absolute value bars, of course, that just is 13. Square root both sides. So the square root of 13 is the distance. In this case, I'm going to be going up the square root of 13 and also down the square root of 13, and that'll give me my focus for those points. So, Wesley, if I'm moving up or down, which variable is that going to affect? The y. So I'm going to start from the center, which is 2, 0. And I'm going to add or subtract the square root of 13. Now, in this particular case, since that's a 0 right there, for my foci, I would just call this 2 plus or minus root 13. Okay. Questions? Okay. All right, so major axis and minor axis are like, in my opinion, about the easiest two things that we have, but they are highly missed because they're a little bit they're confusing. It's kind of like a vertical line has an x equals number equation and a y equals number of facts. It's related. So the major axis is going to be x equals h. X equals h, is that vertical or horizontal? Yeah, x equals a number, like x equals 5 or x equals 2. It is vertical. So if you have a number like x equals 3 or 4, that is a vertical line that crosses the x-axis at 4. If I have y equals -2, that is a horizontal line. So it's sort of backwards from the way it seems that it should be. So this is vertical, this is horizontal. So if we have a vertical major axis, that tells me that we're dealing with a tall ellipse there. And if we're dealing with a tall ellipse, B is greater than A. And if we're dealing with a horizontal major axis, that means I've got a wide ellipse. And if I have a wide ellipse, A is greater than B. So let's see what this looks like. So we have this, it's already in standard form for us. We need the center, the foci, equations for the axes for the following ellipse. So center, Bo, what's our center for this one? Good, 4, -4. So for our foci, we need to be thinking, is this wide or tall? Ethan, is this one a wide or tall ellipse? Tall. In fact, very tall in this case, right? Because that number is a lot bigger. So our center is right here at 4, -4. So, and I always draw myself a little picture here because it's going to help you on not only the foci but the ellipses as well. So, so to find the foci, I've got to do that c squared equals, we're going to subtract the 2, 4 minus 144, which is going to give me -140. So that, of course, is just 140. Square root both sides. So those absolute value bars basically make it where you can subtract, either do 4 minus 144 or 144 minus 4 there. So C is square root of 140. That break down probably 4 and 35. So that's going to be 2 root 35 there. Something like this is probably going to be multiple choice so that it doesn't matter if you remember to break it down or not, because your answer choices won't have both of them there. So we got 2 root 35. That's how much I need to go up or down. And so if I'm going up or down, which coordinate is that going to affect? Y. So my foci are going to be at 4, -4, plus or minus 2 root 35. And I know to add or subtract that to the y coordinate, because this is a tall ellipse, I'm moving up or down on that major axis. My suggestion for major axis and minor axis are to not look at the equation. Because if you look at the equation, sometimes you'll get really mixed up. So I would think about the graph here. So major axis is my longest axis, which in this case, if I look at this graph here, we'll mark it right here, that major axis, that's my vertical axis. Okay? So I'm going to just put myself a little note right here. It's vertical. Vertical lines, what do we know about vertical lines? Or is it x equals or y equals a number? X equals a number. Now this passes through my center, correct? Both of the axes are going to pass through the center. What's the x-coordinate of that center? 4. So it's going to be x equals 4. All right, for the minor axis, okay, this time we're looking at this little short line right here. Is it vertical or horizontal? Horizontal. And horizontal lines, they have a y equals line. What is the y coordinate of my center? -4. So y equals -4. A lot of times students get major and minor backwards because they look at the equation, they think, oh, right there, 4 at smallest, that's minor axis. They look up here and say x equals 4. That is not correct. All right, because x equals 4 is a vertical line. So it's more like this if you look at the equation. So like if you're thinking major axis, you're looking over here. And if you're thinking that number's smaller, so that's the minor, you got to look over here. Okay, questions? Okay, so let's talk about how to put these in standard form. The good news is it's not a lot different than it was yesterday. Even though the equations look quite a bit different, the process is not a lot different than it was yesterday. So we're going to start off doing just like we did yesterday. We're going to group our x's together, group our y's together, move our constant term over to the other side. So it'll look like this. We'll have 4x squared minus 40x plus 9y squared plus 36y equals -100. Okay. Now, our problem is that we cannot complete the square whenever we have a number right here in front of our x squared or our y squared. So what we were doing is we were just dividing that off, right? We were just dividing everything by that number. But it doesn't work with an ellipse because if I divide everything by 4, that gives me 9/4 and well, most importantly, 9/4 right here, right? Which is not going to work. So we can't divide through. So what we're going to do is something a little bit different here. We're going to factor out a 4. So we're going to take a 4 out of both of just these first two terms right here. And so we'll have x squared minus 10x. And now I'm going to put a plus blank right here. So you have to factor that 4 out of both of your x terms. And then we're going to do the same thing over here with this 9. So I'm going to factor out a 9 here. So I'll get y squared plus 4y plus blank. And I need -100 plus blank plus blank. Alright, so we want to complete the square just like we were doing before. The 4 is just going to kind of hang out front. And then so if I'm completing the square here, I need to divide by 2. That'll give me a -5. If I square that, I'll get 25. Now watch out right here. I have added 25 to this side. But what would I have to do with that 4 right there if I was going to put it back together? I'd have to multiply it, right? Which means I would distribute it to that 25. So even though I've added a 25 here, that 4 would have to be distributed to it. It's really like I added 100, right? So with these, we got to take 25, multiply it by 4. We're going to add 100 to the other side. We didn't have to do that with the circles because we didn't have a number out there with the circles. We're going to complete the square with the second one. Same thing as we've been doing. 4 divided by 2 is 2. 2 squared is 4. What number should I add to the other side here? 36. Not the 4, because I've got to distribute that 9. 9 times 4 is 36. So I end up with this equal to 36. Okay. It is not, the last thing we have to do for these is we need this to equal 1. So the only way that I can get 36 to equal 1 without adding an extra term over here to the left side is to divide by 36. So if I divide that right-hand side by 36, I also have to divide this term by 36 and this term by 36. And so this does not always happen, but it happens a lot. 4 over 36 is going to reduce to be 1 over 9. So I get x minus 5 squared over 9. And then 9 over 36 is going to reduce to be 1 over 4. So it doesn't always happen that that 4 and the 9 just switch places, kind of like the 4 went down here and the 9 went here. You're reducing is what you're doing. So, you know, like here I was dividing by 4 to get a 1 over 9. Here I was dividing by 9 to get a 1 over 4 there. And this equals 1.
Where are you getting the 36? Like, can you explain when you get 4 times x minus 5 squared, how do you get the 100 and the 36 plus 100?
So the 100, where I added 25 here, that 4 right there would be distributed to that 25. So even though you added 25, it's really like you added 100 because that 4 is pulled out front. So you have to add 100 to that left right-hand side. Same thing over here with that 4. You'd have to do 4 times 9 and get 36. As you can imagine, that's probably one of the biggest things students do wrong on these problems is they forget to multiply that 25 by the 4 or the 4 by the 9. All right, we do have to tell center, foci, and axes here. So the center would be 5, negative 2. This one would be a wide ellipse because 9 is larger than 4. Center is right here at 5, negative 2. So I've got to do c squared equals absolute value of 9 minus 4. So c squared is going to equal 5. C is the square root of 5. Excuse me. So the foci are going to be to the right square root of 5 and to the left square root of 5. If I'm going to the left and right of that center point, which coordinate should I add or subtract to? X coordinate. So my foci are going to be at 5 plus or minus square root of 5. And then the y coordinate just stays the same. It's negative 2. Then the last thing we need is the equations of our major and minor axis. So for our major axis here, it's going to be horizontal. Horizontal is going to be y equals a number. Sarita, what is our y coordinate right there for our major axis? that center point is on our major and minor axis, right? So what is the y coordinate of that center point? -2. So that is going to be our major axis, right? So it's horizontal. I know horizontal is a y equals line. I look at the y coordinate and it's -2. Okay? Raven, what would the minor axis be? Yes. What would equal 5? Well, 5 is correct. But what, it's got to be an equation, so it's got to have a variable there. Is it y equals 5, x equals 5, y plus x equals 5? Good. So it'll be x equals 5, because x equals is a vertical line. That's, again, easy to get mixed up. Vertical is x equals, horizontal is y equals. And you just pull it from that center point, because that center point is on that those axes, so all the x coordinates have to be the same there. Okay, questions? Okay, let's see. Let me look real quick and see. Okay, so we're going to do the same thing for this one. We're going to have 25x squared plus 100x plus 9y squared minus 18y equals 116. And so we could factor out a 25 out of our x's. So x squared plus 4x plus blank. And we're going to factor a 9 out of our y. So we'll get y squared minus 2y plus blank. And that'll equal 116 plus blank plus blank. We're going to complete this square here. So 4 divided by 2 is 2. 2 squared is 4. What number should I add to the other side? What? Not 50. We want to take not the number right here, but the number up here, that 4, and multiply it by that 25. So we'll get 100. And then 2 divided by 1 is going to, 2 divided by 2 is going to give us 1. 1 squared is 1, so we put a 1 here. But what number do I have to add to the other side here? 9. So I end up with 225 here. What is our last step going to be? Divide by the 225 so that this is equal to 1. So it ends up the same here, x plus 2 squared over 9 plus y minus 1 squared over 25 is going to equal 1. Okay, questions? Okay, what is the center of that, Major? Okay, for our foci, we need to think about whether this is tall or wide. This one's going to be tall. Center is at -2, 1. For our foci, we're going to do c squared equals absolute value of 9 minus 25. That is going to give us c squared is 16. So c is 4. So for our foci, since this is a tall ellipse, major, we got to go up or down, or left or right. Up and down, so we go up 4 and down 4. Since this one is actually a whole number, when we go up 4, what are our coordinates of that point going to be? Yes. Thinking about the x's there, which is wrong. And then, major, what's our coordinates of our bottom? -2, -3. So we're just adding and subtracting 4 from that y coordinate. Yes.
So, yeah, when you're adding and subtracting, why, since it's like taller, why is it not like 1 and 5? Or like you might think from the 1, it's like y. Like 1 is the y. Where it is on the y. So why aren't you doing it on the y? Or are you?
So we are, because what we're doing there is we're really doing -2, 1 plus or minus 4. It's just that for this one, we can actually do 1 plus 4, which gives us the 5 here, and 1 minus 4, which gives us the -3. Does that answer your question? Okay. All right, major axis. Who thinks they know what it is? What do you think, Josie? What equals -2? X equals -2. Okay, so vertical is x equals, x coordinate is -2 there. Good. All right. Matthew? Oh.
What would it be if it was more horizontal than vertical?
Then it would be y equals 1. But in this case, y equals 1 is your minor axis.
No, it's the foci. Like,
Or if it was more horizontal, you would do -2 plus or minus 4, 1. So you would get 2, 1, and -6, 1. If it were horizontal in this case. Like if we switch the 9 and the 25 there. Okay, questions? I need to do one where the x's and y's don't just switch, but I can't remember if that happens on this. I'm thinking it doesn't. Let's do one from your assignment. Alright, so this is going to come from the textbook, which again I'm not passing out because we're just going to really use it on this section. So I've put it on Canvas for you, and over here. So we're going to do one of these together. Well, they don't give you the equation for this, and it gets on my nerves so bad. Alright, let's do number 25 together. I think this is one like we're going to see. So you've got 16 through 28 for your assignments. The first one should be quicker because you just have the equation, and then the 19 through 22 are in standard form. Do not find the vertices. It says to find the center, foci, and vertices and graph the equation. You do not have to tell me the vertices because you're going to do that whenever you graph it. So let's do 25 together, and I'll give you guys a piece of graph paper if you need one for graphing. So for 25, we would have 3x squared plus 18x plus y squared minus 2y equals negative 4. So I would factor out a 3 from my x's. So x squared plus 6x plus blank. And there's nothing to factor out of the y's. So I would just have y squared minus 2y plus blank equals negative 4 plus blank plus blank. So when I complete the square for the first one, I'm going to have 3 times. I'll do x plus 3 squared because 6 divided by 2 is going to give me 3. What number is going to go in that blank right there? 9 here, and on the other side, 27 because I've got to do 9 times 3. Good. And then for the other one, I'm going to have y minus 1 squared, and 1 squared. 1 that goes here. What do I add to the other side here? Just a 1, because I didn't have a number that I factored out. So I don't have to multiply it by anything there. And so that is going to give me 28 minus 4 is going to give me 24. So I wanted to do one like this because for some of these, you're not just going to have the number switch. We got to do divide by 24 here. So 3 over 24, we're just reducing that, which is going to give us 1/8. So x plus 3 squared over 8 plus y minus 1 squared over 24 is going to equal 1. And so we are going to graph this, and I don't have a very good graph here. You're going to have to estimate on this one because you got square root of 8, which is going to be like 2 point something. 2 point. $828. So our center would be at negative 3, 1, and we'd go to the right 2.82 and to the left 2.82. So you're just estimating and get something close, right? There. And then square root of 24 is going to give us something close to 5. 4.89. 89. So we'd go up about 5 and down about 5. And we draw our graph. So I'll give you some graph paper so that you can graph those for me. Center, I do want you to find, which is negative 3, 1. It also asks for the foci. So for the foci, I would do c squared is absolute value of 8 minus 24, which is c squared is going to be, let's see, 24 minus 8 will give us 16. So c is going to be 4. So for my foci, should I go up and down 4 or left and right 4? Up and down. So that's going to be -3, 5, and -3, -3. So I'd add the 4 and subtract the 4 from those points. I think that question is that I make it where you can see it. The answer should be on here. Did I take the picture so you can see everything? I think you should be able to see everything. So this is the teacher book I took the picture of, so it's got the answers there. Now it will, like for example, it gives you the center, it gives you the foci, it gives you the vertices in the answer. I told you you don't have to do the vertices, but I would like for you to graph it. So those are the points that you graph there. You don't have to write them down. We're just going to estimate using decimals, and we're not going to like actually graph. We're not going to like get the plus or minus roots there. For this problem. Yeah. Right, so yeah, so if you get a decimal, just square root it, estimate, and graph it for me. So you don't have to find the exact points there. Questions? Okay. All right, let me give you guys a piece of graph paper for graphing these. And let's say for this one, it's okay with me if you only graph the odds for these. And 16 through 28.